Hi all, welcome to our project presentation on topic Smart Shopping Cart, Automatic Customer Following and Cost Display. My name is Alan George and let me introduce my team members Akshay PS, Alan Thomas, Jacob Munshi and Joel CB. We are under the guidance of Assistant Professor Vijayalakshmi G. These are the contents. We will be talking about each of these contents in detail in the upcoming slides. Moving on, objectives. Develop a smart shopping cart with automatic customer following, bill generation, and multifaceted and encompass various technical, business, and customer-oriented goals. Create a shopping solution that significantly improves customer convenience by eliminating the need for manually pushing a cart, enabling customers to shop without the physical burden of cart management. Mainly, it can be installed in shopping malls and a hypermarket where human labor intervention can be reduced, and also can be installed in hospitals, institutions, restaurants, etc. Applications. These are the main applications: retail stores, shopping malls, smart cities, and IoT customer engagement. Now we want to talk about the customer requirements. The smart shopping cart should autonomously follow the customer as they move through the store, maintaining a safe and appropriate distance. The system should accurately track the items placed in the cart, displaying a real-time list to the customer. The cart should navigate efficiently, avoiding obstacles and providing smooth and collision-free movement. The cart should provide a running total of cost of items as they are added. The cart's interface should be intuitive with easy to use controls and accessible features for customers of all technological backgrounds. Easy deduction of the product cost from the total cost if the item is the cart returned to shelf. Checkout should be expedited, eliminating the need to wait in long queues. Now moving on, work done so far. Finalized the circuit diagram and hardware components based on the remarks from the last evaluation. Coded and tested the program for the project. Successfully completed the breadboard level implementation of the project. Based on the result from the breadboard implementation, rectified the mistakes in the project design and replaced hardware components correspondingly. Successfully completed the PCB design and integrated it with the final product. These are some pictures we took during our project. Now, problem faced by the target users. These are budget conscious shoppers, busy shoppers, elderly or disabled shoppers, families with children, etc. etc. This is the target specification. Now, moving on the bill of materials. Our main component is the Atmega 328P. Then we used ultrasonic sensor, LCD display, RFID reader, motor driver, N20 gear motor, cart body, and we have a grand total about 4070 rupees. Product design. First of all, the sequence diagram. As you can see, we can see the automatic car, ultrasonic sensor, Arduino Uno, DC motor, motor driver, RFID reader, LCD display, and how the data and how the project works. Now this is a user case diagram. Now moving on to the block diagram. As you can see, we are using Atmega 328P microcontroller. Now the power supply is given to each of these components. Now for the automatic following, we are using the ultrasonic sensors. So ultrasonic sensors sense the distance to a person, and this data is sent to the Atmega 328P. This is processed in the microcontroller, and the motor is rotated based on the programming. So L2298 motor driver is used to control the gear motors for wheels. Now moving on to the scanning, RFID tags are used. Then MRC 520 RFID module is used to detect the tags, and this data is sent to the Atmega 328P. The Atmega 328P shows this data through a LCD display. Now push button switches are given there to show the total price and also for the deduction of an item. This is a circuit diagram for automatic following. This is a circuit diagram for product scanning. Now these are the programs. So first of all, program for automatic following. Now the program for product scanning. This is a flowchart for product scanning. So first of all, start initialized controller and LCD. Is push button switch pressed? If it is yes, then the is tag detected. If it is yes, read the tag and detect the product. If no tag is detected, it go back to the initial stage. Then display item details. Same goes for if push button switch pressed. If it is no, then the tag detected. If it is yes, read the tag and add the product. Now last, display the item details, add item cost to the total bill and stop. This is just the algorithm for the above also. Now this is a PCB layout for automatic following, and this is the PCB layout for the production. PCB implementation. So these are the pictures we took for our PCB implementation. This is the PCB for automatic following. Now this is a need matrix. As you can see, there is one side you can see the customer needs, and the metric we used for this need matrix is shown also there. So safety, navigation, display, battery, load capacity, budget, barcode scanning, aesthetics are the customer used against the metrics like material weight, screen size, etc. Or the component specification. First of all, the Atmega 328P high performance low power 8-bit microcontroller, 32K bytes flash memory, advanced RISC architecture, 1K bytes EEPROM. Operating voltage is 2.7 volt to 5.5 volt. Ultrasonic sensor. Power supply is about 3.3 volt to 5 volt. Operating current 8 microampere. Working frequency is 40 Hz. Ranging distance 3 cm. To 350 centimeter. Resolution is about 1 centimeter. Measuring angle 50 degree. Now the motor driver input voltage 3.3 volt to 40 V DC. Driver L29810 dual edge bridge DC motor driver. Power supply DC is a 5 volt to 35 volt compatible with the Arduino Uno. Now moving on to the next, LCD display, RFID reader and gear motor. LCD display specification is about 16 into 2 alphanumeric LCD display module. Operating voltage is about 4.5 volt DC to 5.5 DC. Can display 16 into 2 32 alphanumeric characters. LED backlight enables optical viewing. RFID reader type RC522. Operating voltage 3.3 volt DC. Operating current 30 to 26 microampere. Working frequency is about 13.56 megahertz. Car reading distance 0 to 100 mm. Now gear motor operating voltage and no load current microampere 0.06 ampere. Lightweight, high torque and low RPM. Now moving on to the software requirements, we used Arduino Uno, Arduino IDE, Tinkercad, MS Office for our project. Now this is a work plan. Problem faced during the design and the solutions. Sensors. The initial product design, automatic customer following featured 2 IR sensors and one ultrasonic sensor. However, upon completing the breadboard implementation, it became evident that the configuration was not effective. Subsequently, we made the decision to transition a setup incorporating 3 ultrasonic sensors instead. Gear motor and wheel. The initial design had 4 wheels connected to 4 gear motor for the movement of the car. Later, we understood that the gear motor and wheels have stability issues and load is applied, and 4 wheels is not suitable for proper turning of the car. So we made a design change in there. So only 3 wheels of the which of them is only connected to DC motor, and while the third one is normal wheel which will help in the directional movement. For this we choose more stable gear motor and its corresponding wheels. Now motor driver. We initially planned to use L293D motor driver for our product, but after the project design modification we understood that L298 is more suitable motor driver for the, so we switched to L298 motor driver. Now these are the test results. First of all, this is the breadboard implementation results. So this is automatic customer following. Now the course display through LCD screen. Now this is the final product. Conclusion. In conclusion, the Smart Shopping Cart project brings together advanced technology to revolutionize the shopping experience with features like self-navigation, personalized recommendation, and automatic billing. It redefines how customers interact with retail spaces. By seamlessly incorporating autonomous navigation and personalized features, it addresses the evolving expectations of modern shopping. The project prioritizes user-friendly interfaces, real-time billing, and data security, making shopping more efficient and enjoyable. So we are going to talk about our achievements. This is we completed the YAP idea submission. This is a certificate we got for that. Now we submitted our conference paper to KT TechFest conducted in Hialeah College of Engineering, Palakkad. Now we also our paper got accepted at IGRT 2024. So these are the reference of our project. Thank you.